Hey everybody, I'm Tim Brzezinski. Today we're going to explore how to use GeoGebra 3D with augmented reality to engage students, to actively engage students in modeling the everyday 3D world around them. Thank you for joining me. We're going to get started right away. So if you have your smartphone or a tablet with you, go grab it. Also, if you're watching on a computer, Chromebook, whatever, you can go there as well too. But let me share my screen and we'll get going here. So I'm excited to do this. Thanks for joining. So we're going to actually work on both devices in this brief screencast. I have my iPhone displayed right here. Over here, this is going to imitate an Android. This is my Acer Google Chrome tablet 10. All right. But right here, just to give you a quick intro in terms of getting set up and started really quickly, if you can go please to, here it is right here, this URL. All right. I made it a tiny URL, tinyurl.com/ggb3dar. That URL will literally take you to the links on App Store and Play Store for the Android operating system, okay, that you need to do, all right? That tiny URL right here, again, obviously, if you're not watching this live, you could pause it and go there and do whatever, but I'm just going to keep this as short as I can. I'm going to go there. That takes you this takes you to this page right here, this quick Google Doc. If you have an iPhone or an iPad, all you want to look for in the App Store is GeoGebra 3D Graphing Calculator. Just download it, okay? It takes a couple seconds, and that's just one app. That's all you need. That's the logo you want. Don't download the Augmented Reality app with the AR letters on it. What you want from App Store is this right here, okay? It's got the pyramid there. If you are an Android user or have a non-iOS device, as I like to call it, okay, you're going to download two apps. The first app is the same GeoGebra 3D Graphing Calculator. Again, that URL takes you right there if you go to it. All right. Now, you can download that, but yeah, on an Android operating system, if you want to activate augmented reality on that type of device, you need a second app called AR Core by Google. Okay, it's a hidden app, if you will. You can't open it on your device, but basically it's behind the scenes. And AR Core by Google actually empowers lots of apps that can activate whatever. All right, so that's what you want to do right there. Okay, social media links if you want right here, but regardless, again, iPhone, iOS, get this app right here. Android, you need two apps, the 3D Graphing Calculator and AR Core by Google. These two work together to provide the ideal augmented reality experience on an Android device. Okay, so with that said, here's the goal for today. All right, I'm going to go up here and try to show you what I have here. Just give me a second. We're going to recreate this. Let me just go to camera right here. On my desk, I have a rectangular prism, right? We're going to take a baby step approach here. We're going to start with the easiest solid there is, really. It's kind of like a rectangular prism, right? Students work with. Okay, so here we have a rectangular prism with dimensions 9 8/10 centimeters, 19 6/500 centimeters height, and across we have 4 6/500 centimeters right there. Okay, so we're going to actually proceed to do that within GeoGebra's 3D Graphing Calculator. Now, I could go ahead and open up the 3D app on my phone here and start playing around and building, and many of your students may want to do that, but I find it easier personally to create on something with the keyboard, but again, I let students choose. They should be the ones making the choices here. So I'm going to go into Chrome, whatever. I'm going to go to my GeoGebra page. All right, you need to have a GeoGebra account to do this. So if you don't, all right, just go ahead and watch, and you could pause it, watching this afterwards, and do it. But I'm signed into GeoGebra, as you can see right here. So I'm just going to quickly go to the 3D calculator, the right over here. Okay, it's a quick link. Let's go to 3D, and here we are. All right, we have an x-axis that's red, the y-axis is green, and the z-axis is blue. Okay, so we talk about positioning. Let me see if I could do this here. We talk about positioning this thing here, right? Let me just kind of go over a little bit here and show it on my camera again so you can see it side by side. I always love to ask kids, where is the best place? I want to position this, right, on my computer screen over here. Okay, so where would it be good to plot it? Usually kids tell me, well, like at least you want this rectangular face on the gray plane there, right? Yeah. So talk to me about coordinates now. What's the best coordinate number to use in any type of plotting? And kids always shout either 1 or 0. And I'm like, but of the two, which is easiest? Kids always tell me 0. Okay, yeah, so in fact, we can actually plot 1 point. Let's type it in, 0, 0, 0. Like such, we put it right there. Okay. Now, this thing is 9 and 8/10 units of centimeters across. So if we traveled on the x-axis here, right? See, I don't tell kids how to plot in 3D necessarily. I think they should just start plotting points and figuring patterns out for themselves. Again, obviously, you can do this after you do 2D, but right here, let's actually, save time. 9 and 8/10, right? 0, just typing it in, like so. And if I zoom out enough, I can see it right there. Oh, by the way, little trick. When working in GeoGebra online, any of the apps, if you hold the Shift key down and just drag, you can drag it this way while holding Shift. A little trick here, quick and easy. All right. So now there's B. Now let's get that prism back up and running here so we could see it side by side again. So what about here? We're 4 and 6/500ths going that way, right? So therefore, okay, well, we got to plot a point along the y-axis now, right? That's 4 and 6/500ths units up. So we go ahead and do it right there. So that would be what? 0, 650, right? Again, now is plotting 0, 0, 4 and 6/500ths wrong? No. I mean, that's just another possible setup for this thing, right? But I'm not going to choose that. So, and then finally, so kids will figure out, working together or working by themselves, the coordinates of the last one is going to be what? 9 and 8/100ths, right? 4 and 6/500ths, and then 0. So there it is. So now what we're going to do, let me actually show more of the screen here so it's bigger. Now what we can do here is literally go make the polygon. Now there is a polygon tool here in the tool suite, the tool suite right here, show more. All right. Polygon is under lines and polygons right there. We can go ahead and start, just like Geometry Sketchpad, if any of you are familiar with that program, I used it for years. Just start plotting one vertex, go in a kind of a consecutive order there, and you want to close it by going to the first one that you made right there. There it is. Okay. Now, at this point, now that just created a bunch more items right here. We don't have to pay attention to that for right now, at least. Okay. In fact, but one thing I do want to do is actually, if you hold the Shift key down, hold down Shift, and let's highlight A through D. All right. Let's right-click on it. Right-click on that, go to Settings, and where it says Show Label, let's choose Name and Value. The value of a point are its coordinates, right? Pretty powerful. Now, at this point, there's 2 ways you can go about doing this, definitely more. You can have kids plot the other 4 vertices, right? It's going to have a z-coordinate of 19 and 6/500ths, or we could actually use some transformational geometry here, because literally, if I'm talking transformational geometry, like say, we talk about triangles, parallelograms, we always work in 2D, but transformational geometry, translations, rotations, those principles still apply in 3D. So why aren't we using it more, right? So let's actually go with that approach here. So we can actually say we need a vector, right? So the vector is going to be vectors by default start at 0, 0, 0, but I can actually go ahead and just put it in there. I don't need to, but it's going to take any item and translate it. If we want to translate it straight up, it's got to look like this, right? So see how that arrow points directly up there? So vector right there. So it called it vector U. Vector U takes any object, and it's just, that's the direction right there, 0, 0, 19.65. So now, see how GeoGebra called the polygon Q1? So if I actually type in, I can actually do 2 different things. I can go here, use the tools. I can go hit the Translate by Vector tool, like so. And all I do is touch the polygon, touch the vector, and there it is. Okay. Now I can do the same thing for B and touch U. I can do D and touch U. I can do A and touch U, and then C, and then touch vector U. And look at that. There we go. Okay. Pretty cool, right? Translated that. So that looks like those are 2 of the bases of my prism that you see here. So now we have to draw in the other 4 rectangles. That's easy. We could use the polygon tool a couple more times, but let me hide you. We don't need that right now. I like to just simply use see how when we use the polygon tool, it just put the word polygon in there. So I find it faster to just type polygon and then type in the vertices, C, A, B, This one here is B prime, right? And A, B, B prime, A prime, right? And then like so. Okay, so I can obviously conclude this and do the other couple faces, but I'm gonna undo for a second. I want to show you something else that's pretty cool. In fact, I'm actually gonna undo a bunch of times and hide all this. And you're like, what are you doing? You know, but hey, that might be actually I need the vector there. Let me read, oh, whatever. Vector 0. Hang on a second. 0, 0, 19.65. There it is. Because it by default it starts at the origin anyway. It says it. But now, so there is also a prism tool. There's a prism tool here, basically where you have a polygon and you enter the height value there. So see how the polygon is called Q1? The height of that thing is 19.65. See how it made it really quickly right there? But I like to actually go a bunch of ways. In transformational geometry, I think kids should be working with vectors and translating by vectors. You see what I'm saying? Even though there's a much faster way to make it right here. So we've just built this prism. But now, you know, you're looking at the screen, you're like, Tim, it's nice, but all that label and stuff is ugly. How could I get rid of that quickly? I'm going to show you a nice quick way to do that here in GeoGebra 3D. All right. The key is first to it. Now, all of these items here are arranged by construction order. So what we're going to do is we're going to go to settings here. Settings. All right, the settings gear. Go to this funky looking cubic symbol where it says sort by. Do object type. Object type is all the segments together, all the everything together, and hit show auxiliary objects too. There's more that's in there than that, but that's all we need. And so now, to format this thing really nicely, we could just simply click on a category. Like for example, if I do quadrilateral, or see these faces here, if I click on the word quadrilateral, all of them highlight, right click, go to settings, and then just simply undo show label. But oh, those are segments, my bad, not quads. Click here where it says segment. Right click, go to settings, and then just check show label, uncheck. See how it hit it all there? Okay. Now, to save time, I'm just going to leave it as it is. We could format this thing prettier. I'll do that in another screencast in terms of formatting and stuff, but let's just leave it for now to save time. We could leave vector U there. Why not? Okay. But now, if I want to hide the plane and the axes, I can just simply right-click here and uncheck show axes. Right-click, uncheck show plane. Some of you may want it. It's up to you. Again, if you hit the shift key, you can kind of move this over a little bit. All right. Now, what we do is we go here. Now, here's the beautiful part. That the hard work is done. Now comes the icing on the cake. We're going to open this up in augmented reality and see how well this thing is built to scale. All right, so let's go to File. If I'm logged into GeoGebra, I can save it. And I'm going to do, say, AR Talk, right, Demo 1. And I'm going to make it public. So there's no findable. If you make it shared, you get on Android, not yet on iOS. It's a workflow issue they're working on, but it's fine. If you make it public, hit save. I created on my computer, and now I'm going to open on my devices. No matter where you are, you'll be able to open this on your device if you have GeoGebra 3D installed on your device here. Okay, so let's actually do that now. All right, I'm going to get my iPhone back. I have the Android up here. I'm going to get my iPhone back and running. All right, let me just see here. Give me 1 second. Screen share. There we go. And let's see. Before we do that, I actually have to go and I have to go turn the light on here because augmented reality needs light. Put the light down in the room. And here we go. So now, when we just simply did this here, the thing is, every GeoGebra file that you save, it automatically assigns it a code, and it's small right there. But what I'm going to do is I'm going to go back into this doc right here, tiny URL, and I'm going to paste it for you to see there. So I'm going to leave that up and running on the side. And here's what you want. Here's the fastest way to get what I just made, or anything you make, anything a kid makes, saves it to their GeoGebra account, right? Then it gives it a URL code. All right. Now I'm going to take that code, make it even bigger here. There we go. And what I'm going to do is open up the 3D graphing calculator. I go up here to the search on my iPhone in this case. I go to search. And I can just, where it says search, I can type in those characters just like that. I find that to be the most efficient way to do it because there's only one thing that'll pop up. You could type the title in, but there might be tons of resources named demo one kind of thing. You might have to scroll through a list. PW3J8N. And then return. There it is. And if you're watching with me and you type those characters in on your device, you should be able to access what I just made in the last 5 minutes. All right. So let's tap it. Now it's way over to the right here. So take two of your fingers and move it over a little bit there. See what I mean? And now, all right, we'll put, now there's an AR button right over here. So what I'm going to do is I'm going to, let me get this side by side here. I'm actually going to take this and put it in my environment here. Give me a second. Hit the AR button. There we go. Aim it to the floor. It's a little slow, a little lag here. There's a square that appears. Tap the square, and there it is. Okay. Now, the key is to have an adequate light source with augmented reality, but not only that, when you pick it up, go slow. If you go too fast, it can freeze on either iOS or Android. It doesn't matter. So I'll pick it up with two fingers, and now augmented reality brings to the table what has never been able to be done before in math ed. We can superimpose it over that and look to test the accuracy of our models. And the better it is actually, the better it's actually built and more accurate it's built, the more likely it is that model wants to simply latch on and attach to it and not leave. I'm going to test it out right here. So give me a second. Let's watch. All right. Now the vector's there. See? That's pretty cool. We could look at it straight on. Again, we're not shooting a rocket to the moon here. Let's look at it from like up above a little bit, try to get a better view. Hang on. Now, not perfectly perfect, I get it, but that's not bad, right? You take a screenshot, but it's pretty cool because in terms of modeling other things, right? Now, granted, this thing is foamy. It's like, it could be like, 7/10, whatever. Not perfectly perfect, but again, it should fit naturally. We could even go inside of it, right? And do sorts of things. Now, if I make this height a slider, many math apps use sliders, I could actually have the height be a slider and I could see it going up and down in augmented reality, right? Pretty cool. Let's take a look at the same. Let's open the same one on the one with Android with AR Core by Google. Okay, I want to come across as device agnostic here, so we'll do it on here too. All right, so we'll open up the 3D calculator on my Acer Google Chromebook tablet. And let's see, what was the code there again? That's what I got to type in. So let me go type it in once more. AW, what was it? PW, so AW, sorry, AX, PW. We're almost done here. 3 JAN, J8N, and there we go. See, the only one that shows up. Nice way. Now there it is. Okay, I could bring it a little closer if I want. Looking at it on there. So now hit the AR button right there. See, AR Core by Google, that purple logo. That's what makes that button appear. If you downloaded the 3D graphing calculator without the AR Core by Google, that AR button wouldn't be there. So but that's what powers this to work. Hit AR. Now, he used to go slow. On an Android, it actually shows a square and like an isometric tessellated floor. It's pretty cool. But that's a great sign. Just tap it, and then you have it now on an Android. Okay, so we go here. Again, go slow. Key is to go slow. All right. Back it up, and we'll see how well this fits. Turn it with your fingers, just like you would like on look at anything else on an Android or whatever. Well, see, oh, there we go. Let me stand up. Try to get a better perspective here. And again, I know not perfectly perfect, but again, there we go. This one, AR Core is a little bit shakier than AR Kit, but again, AR Core, every update that I get to update it on my device, it gets better and better and better. Again, this is still for both Apple and Google. It's still a new technology. It's just, but it's freaking believable that you could just take things and place it right in your environment and have it literally be as such right there. So there you go. That's on an Android. Right. So yeah. Lots and lots of cool things that you can do here with augmented reality. This is the first of a series, and this is probably the longest of them all because we took time to take these things and download them and such. But one thing that I do want to tell you is I'm going to be doing a ton of these short. I'm going to make it shorter than this one for each next one of the next ones here. But wait, where'd you guys go? Sorry, there you are. All right, we're going to be doing a bunch of these series, but again, kids can build in 3D all over the place. It's fun. It's a fun experience and interactive. And honestly, we could up the ante a little bit. Next one, we're going to do something like this, right? This block's half the height. And oh, how about a right triangle here? How could we make this perhaps, right? And what if we put this, what if we actually did it this way? Or let's differentiate now. Let's do it this way. You see, not every kid in class has to be working on the same activity. Everybody should be actively engaged, right? But for kids who this would be an absolute joke by day 2, well, why don't you have them work on something like this? And even so, geometry teachers, this one I love to demonstrate the most, Toblerone candy. The bases are equilateral triangles. So if this was -1, 0, 0, and this was 1, 0, 0, the z-axis going right at the center, what would the coordinates up here be? Ooh, now we got to use properties of special right triangles that we had there, right? You see where I'm going. And even in Algebra 2, let's take a different approach. Algebra 1, Algebra 2, pre-calc, when you study, hey, 2 of these faces take the shape of a V, don't they? And, oh, wait a minute, a V, what graph looks like a V? We're going to model this also with an absolute value function that's sloped, if you will, z to x to scale. If your kids can work in 2 dimensions, many of these kids can work in 3. So let's start doing it. GeoGebra 3D with augmented reality provides the optimal environment for which kids can actively engage, have fun. And with AR, now they put that model to the test. A lot more coming. Next few are going to be much shorter. That's my goal. I'm Tim Brzezinski. Thank you for watching. If you like what you see, feel free to subscribe to the channel. There are a lot more how-tos, tutorials. Going to have one coming up later today, 3 minutes, in terms of open up resources and stuff. But thank you for watching. Have a great Friday.